4. Strategic frameworks and models. Beyond core operational processes, effective PNSCM relies on strategic frameworks and models to guide decision-making, optimize performance, and align activities with business objectives. This section explores several influential frameworks. A. Strategic sourcing, revisited in strategic context. As previously introduced, strategic sourcing represents a fundamental shift from traditional, price-focused purchasing to a proactive, long-term, and holistic approach aimed at maximizing total value and aligning procurement with overall business strategy. Its core tenets include minimizing the total cost of ownership, TCO, mitigating supply chain risks, building strong, collaborative supplier relationships, accessing innovation, ensuring quality, and enhancing sustainability. In the context of strategic frameworks, strategic sourcing serves as a primary engine for supply chain optimization. By systematically analyzing spend, understanding market dynamics, rigorously evaluating suppliers on multiple criteria, and negotiating comprehensive agreements, organizations can optimize their supply base, achieve significant cost reductions beyond purchase price, improve the quality and reliability of inputs, foster supplier-led innovation, and build more resilient and adaptable supply chains. Real-world examples from companies like Apple, Toyota, P&G, Walmart, and others demonstrate the tangible impact of strategic sourcing on competitive performance. Successfully implementing strategic sourcing often requires dedicated cross-functional teams involving procurement, operations, finance, R&D, and other relevant stakeholders. A crucial element enabling the success of strategic sourcing is the parallel development of strong supplier relationship management, SRM, capabilities. Moving beyond purely transactional interactions to build trust, transparency, and collaboration with key suppliers is essential for achieving the broader goals of strategic sourcing, such as joint innovation, proactive risk management, and maximizing long-term value. SRM provides the relational foundation upon which strategic sourcing initiatives can thrive. V. Category management. Category management is a strategic procurement approach that involves segmenting an organization's total spend into logical groupings of related products or services, known as categories, e.g., IT software, professional services, logistics, direct materials like steel or chemicals. Each category is then managed holistically as a strategic business unit, with dedicated resources, often category managers, developing deep market expertise and implementing tailored sourcing and supplier management strategies for that specific area. The implementation of category management typically follows a structured process, such as the CIPS category management cycle. This cycle outlines 4 main phases. Initiation, defining the scope of the category, identifying stakeholders, securing resources, forming a cross-functional team, and establishing project governance. Analysis, conducting thorough analysis of category spend patterns, understanding business requirements, researching the supply market, suppliers, trends, risks, and assessing supplier capabilities and relationships. Strategy development, creating a specific category strategy based on the analysis, outlining the sourcing approach, e.g., competitive bidding, partnership, risk mitigation plans, supplier relationship management approach, and quantifying expected benefits and resource needs. Implementation and continuous management, executing the sourcing strategy, tendering, negotiation, contracting, managing the transition, implementing change initiatives, continuously monitoring supplier performance and market dynamics, managing relationships, and reviewing/refining the category strategy over time. Key principles underpinning effective category management include maintaining a customer-driven focus, leveraging data and market intelligence for insights, ensuring cross-functional collaboration, applying appropriate supplier relationship management techniques, and utilizing core procurement levers like spend aggregation, consolidation, standardization of specifications or processes, and potentially outsourcing non-core activities. The benefits of adopting a category management framework are significant. It allows procurement teams to develop deep expertise in specific supply markets, consolidate spend more effectively to leverage buying power and achieve better pricing and terms, tailor sourcing and supplier management strategies to the unique characteristics of each category, e.g., using the Kraljic matrix within a category, improve supplier performance and foster stronger partnerships within key categories, better align procurement activities with the specific needs and objectives of internal business stakeholders, identify opportunities for innovation and risk mitigation specific to the category, organize procurement resources more effectively. Category management provides an organizational structure and methodology for procurement. It moves away from managing individual purchases or suppliers in isolation towards a more strategic, market-focused approach. By grouping related spend, organizations can apply strategic sourcing principles and SRM techniques more effectively within defined segments, ultimately driving greater value and efficiency from their procurement activities. C. Supplier Relationship Management, SRM. Supplier Relationship Management, SRM, is a strategic and systematic approach focused on evaluating, managing, nurturing, and developing relationships with suppliers, particularly those deemed critical or strategic to the organization's success. It signifies a fundamental shift from viewing supplier interactions as purely transactional, focused on cost and immediate needs, to building long-term, collaborative, mutually beneficial partnerships aimed at maximizing shared value. The importance of SRM has grown significantly due to increasing supply chain complexity, volatility, and the recognition that suppliers can be sources of innovation and competitive advantage. Effective SRM contributes to enhanced supply chain resilience, improved supplier performance, quality, delivery, proactive risk mitigation, greater cost optimization, beyond price negotiation, access to supplier innovation, and stronger alignment with strategic objectives. Implementing SRM involves several key frameworks and processes. Supplier segmentation. Not all suppliers warrant the same level of relationship intensity. Segmentation involves categorizing the supply base using criteria like spend, criticality, risk, and potential for collaboration. Tools like the Kraljic matrix or tiered models, e.g., strategic, important, transactional, help identify key suppliers requiring strategic partnership approaches versus those managed more transactionally. The CIPS relationship spectrum illustrates the range from adversarial to collaborative/partnership models. SRM process models. Structured approaches guide SRM implementation. Gartner proposes a 4-step model: design, define program, align, plan details, roles, launch, execute pilot, communicate, govern, review, optimize. Other models emphasize segmentation, tailored strategy development for each segment, execution of relationship activities, and continuous performance measurement and improvement. Governance structures, establishing clear roles, responsibilities, communication protocols, and processes for managing the relationship, resolving issues, and making joint decisions is crucial. Key activities within an SRM program include ongoing supplier performance management, using KPIs, scorecards, regular reviews, proactive risk assessment, and mitigation planning, fostering open communication and collaboration. Joint problem solving, managing contracts effectively, identifying opportunities for supplier development and capability building, and engaging in joint innovation initiatives. Supplier Relationship Management, SRM. Software platforms are increasingly used to support these activities. They provide capabilities for centralizing supplier data and documents, automating workflows like onboarding and performance tracking, managing risk and compliance information, facilitating communication and collaboration, and providing analytics and reporting. Leading vendors in this space include GP, Coupa, SAP Ariba, Oracle, Jagger, Ivalua, Kodiak Hub, Zycus, and Medius. SRM Key Performance Indicators, KPIs, are used to measure the success of the relationship and supplier performance against agreed objectives. Common metrics include on-time delivery rate, quality metrics, defect rate, compliance to specifications, cost competitiveness/reduction, compliance rate, contractual, regulatory, ethical, lead time, responsiveness, supplier availability, contribution to innovation, and sustainability performance. SRM represents a significant evolution from traditional supplier management, which often focused primarily on monitoring performance against contracts, supplier performance management, SPM. While SPM remains a component of SRM, the latter adopts a more strategic, forward-looking perspective. It emphasizes proactively building trust and collaboration with key suppliers, viewing them not just as vendors fulfilling orders, but as strategic partners capable of contributing to joint value creation, innovation, and risk reduction. This partnership approach aims to unlock benefits beyond simple cost savings and operational efficiency, fostering mutual growth and competitive advantage. D. Kraljic Matrix. The Kraljic Matrix, first introduced by Peter Kraljic in a 1983 Harvard Business Review article, is a widely used portfolio analysis tool specifically designed for procurement and strategic sourcing. It helps organizations segment their purchases or suppliers based on two critical dimensions: profit impact, typically plotted on the vertical axis, representing the item's impact on the bottom line, e.g., through spend volume or value contribution, and supply risk, plotted on the horizontal axis, representing the complexity or vulnerability of the supply market, e.g., availability, number of suppliers, potential for disruption. The primary purpose of the matrix is to enable differentiated purchasing strategies. By categorizing items into one of four quadrants, procurement can allocate resources more effectively, tailor supplier relationship management approaches, and strategically balance cost optimization against supply security. The four quadrants and their associated strategic implications are: non-critical items, low profit impact, low supply risk. These are typically standard. Low-value items readily available from multiple suppliers, e.g., office stationery, basic cleaning supplies. Strategy: focus on process efficiency. Simplify and automate the purchasing process, e.g., using e-procurement systems, catalogs, standardized products, and minimize administrative effort. Ensure efficient processing rather than investing heavily in supplier relationships or complex negotiations. Leverage items, high profit impact, low supply risk. These items represent a significant portion of spend, but are available from numerous competitive suppliers in a stable market, e.g., commodity raw materials, standard IT hardware. Strategy: exploit purchasing power. Use competitive bidding, tenders, and auctions to drive down prices. Consolidate volumes with fewer suppliers to maximize leverage. Engage in aggressive negotiation focused on cost and favorable terms. Focus on maximizing value and cost savings. Bottleneck items. Low profit impact. High supply risk. These items have a relatively low impact on overall costs, but are difficult to source due to factors like limited suppliers, specialized technology, or potential for disruption, e.g., unique spare parts, specialized chemicals. Strategy. Ensure supply continuity. Focus on securing supply rather than aggressive cost reduction. Seek alternative suppliers or substitute materials if possible. Consider holding safety stock or buffer inventory. Develop good working relationships with existing suppliers to ensure reliability. Implement risk mitigation plans. Strategic items. High profit impact. High supply risk. These are items crucial to the organization's product or service, representing high value and sourced from complex or high-risk markets, e.g., critical raw materials with volatile supply, core technology components, highly customized services. Strategy. Build strategic partnerships. Develop long-term, collaborative relationships with key suppliers. Engage in joint planning, forecasting, and potentially co-innovation. Manage risks proactively through close communication and contingency planning. Focus on mutual value creation, trust, and strategic alignment. The Kraljic matrix is a foundational tool applied within strategic sourcing and category management processes to guide the development of tailored strategies for different parts of the procurement portfolio. It helps prioritize management attention and resources towards the items and supplier relationships that matter most. While powerful, the model has limitations. Its effectiveness depends on accurate assessment of risk and profit impact, which can be subjective. It can sometimes oversimplify complex market dynamics and may not capture all relevant risk factors. Nevertheless, it remains a valuable framework for structuring strategic procurement thinking. Table 3. Kraljic Matrix Summary. Quadrant name. Profit impact. Supply risk. Characteristics. Recommended strategy. Examples. Non-critical. Low. Low. Low value. Many suppliers, standard items, easy to switch. Ensure efficient processing, automate, standardize, minimize effort. Office supplies, standard fasteners, cleaning services. Leverage. High. Low. High spend value, many competitive suppliers, standard specifications. Exploit buying power, competitive bidding/auctions, negotiate price aggressively, consolidate volume. Commodity raw materials, standard IT hardware, logistics. Bottleneck. Low. High. Low value but critical, few suppliers, potential disruption, unique specification. Ensure supply continuity, seek alternatives, hold safety stock, build supplier relationship, risk mitigation plans. Specialized spare parts, unique chemicals, custom tooling. Strategic. High. High. High value/spend, critical to product/service, few suppliers, complex market. Build long-term partnerships, collaboration, joint innovation, close relationship management, proactive risk management. Core technology components, critical raw materials, complex outsourced services. E. Total cost of ownership, TCO. Total cost of ownership, TCO, is a critical financial analysis methodology used in procurement and supply chain management to evaluate the complete cost associated with a product, service, asset, or supplier relationship over its entire life cycle. It fundamentally shifts the focus from the easily visible initial purchase price to a more comprehensive assessment that includes all direct and indirect, often hidden, costs incurred from acquisition through operation to disposal. The components included in a TCO analysis are extensive and can vary depending on the specific item being assessed, but typically encompass acquisition costs, initial purchase price, taxes, duties, transportation, shipping, handling, installation, configuration, customization, and transaction costs, e.g., supplier search, negotiation, contract development. Operating costs, energy consumption, utilities, consumables, spare parts, labor required for operation. Maintenance and repair costs, scheduled maintenance, unexpected repairs, service contracts. Inventory and holding costs, costs of storing inventory, capital tied up in stock, insurance, risk of obsolescence or spoilage. Training and support costs, costs to train personnel on usage and maintenance. Quality costs, expenses resulting from poor quality, such as inspections, testing, scrap, rework, warranty claims, product recalls, and customer returns. Risk costs, potential costs associated with supply disruptions, supplier failure, compliance issues, or reputational damage. End-of-life costs, costs for decommissioning, disposal, recycling, or site remediation. Residual value, the estimated resale or salvage value at the end of the asset's useful life, which is typically subtracted from the total costs. Calculating TCO can range from simple formulas, e.g., initial cost plus operating/maintenance costs, residual value equals TCO, to complex models involving activity-based costing, ABC, principles applied across organizational boundaries, and the discounting of future costs to their present value to account for the time value of money. TCO analysis is a powerful decision support tool with broad applications in PNSCM. It is used for supplier selection and evaluation, comparing potential suppliers based on their overall lifecycle cost impact, not just their quoted price. This enables identification of suppliers offering the best long-term value, even if their initial price is higher. Make or buy decisions, assessing the full cost implications of producing in-house versus outsourcing. Negotiation, providing leverage by demonstrating an understanding of all cost drivers beyond the purchase price. Budgeting and forecasting, providing a more accurate picture of future expenditures related to an asset or service. Identifying cost reduction opportunities, highlighting areas within the life cycle, e.g., maintenance, energy use, disposal, where costs can be optimized. Asset management, informing decisions about asset replacement or upgrades. The adoption of TCO is fundamental to strategic procurement and value-based SCM. It provides the necessary financial justification for moving beyond short-term cost minimization, lowest price, towards decisions that maximize long-term value and account for the full spectrum of costs and risks associated with procurement choices. By quantifying the often overlooked indirect costs, TCO enables a more informed, strategic, and ultimately more profitable approach to managing supply chains. F. Supply chain network design and optimization. Supply chain network design, also referred to as network modeling or optimization, is the strategic process of determining the optimal physical structure and operating policies for a supply chain. It involves making critical decisions about the number, location, capacity, and function of key facilities, suppliers, manufacturing plants, warehouses, distribution centers, and the transportation links connecting them. To ensure the efficient and effective flow of goods from source to customer. This process typically utilizes mathematical models, simulation, and data analytics to evaluate different network configurations and identify the design that best meets the organization's strategic objectives. The primary goals of network design and optimization are multifaceted, aiming to achieve an optimal balance between potentially competing objectives. Cost reduction, minimizing total supply chain costs, including transportation, inventory holding, warehousing, manufacturing, and procurement expenses. Service level improvement, enhancing customer satisfaction through faster, more reliable deliveries and better product availability. Risk management and resilience, designing a network robust enough to withstand disruptions, e.g., geopolitical events, natural disasters, supplier failures, and adaptable to changing market conditions. Agility and scalability, creating a network structure that can efficiently scale operations up or down in response to demand fluctuations or strategic shifts. Sustainability and ESG performance, optimizing the network to reduce environmental impact, e.g., minimizing transportation emissions, optimizing resource use, and ensure ethical and social compliance. Supporting strategic decisions, providing insights for decisions related to market entry, mergers and acquisitions, or major capital investments. Designing or optimizing a supply chain network requires careful consideration of numerous interacting factors. Customer locations and service level requirements, e.g., delivery speed. Demand patterns and forecasts, volume, variability, seasonality. Product characteristics, e.g., value, size, perishability, shelf life. Supplier locations and capabilities. Manufacturing facility locations, capacities, and costs. Warehouse and distribution center locations, capacities, and costs, including labor. Inventory positioning strategy, centralized versus decentralized, safety stock levels. Transportation options, modes, routes, costs, lead times, reliability. Taxes, duties, and trade regulations across different regions. Potential risks and disruption factors. Sustainability goals and constraints. Technology infrastructure and capabilities. Capital investment requirements. Various analytical techniques and tools are employed in network design. These include mathematical optimization models, e.g., linear programming, mixed integer programming, simulation modeling, including the use of digital twins to create dynamic virtual replicas, scenario planning, what-if, analysis to test different assumptions about demand, costs, or disruptions, and advanced data analytics powered by AI and machine learning. Specific optimization areas include deciding on facility locations, greenfield/brownfield analysis, selecting optimal transportation modes, determining ideal inventory levels and placement, optimizing sourcing strategies, and assessing location-specific risks. Challenges in network design arise from the increasing complexity of global supply chains, heightened market volatility and demand uncertainty, shifting consumer expectations, e.g., faster delivery, growing pressure for sustainability and ethical sourcing, cost fluctuations due to inflation or geopolitical factors, and the need for accurate, comprehensive data. Supply chain network design represents the strategic architecture upon which all operational flows depend. Decisions made at this level regarding the number and location of facilities, inventory deployment, and transportation structures have profound and long-lasting impacts on a company's cost structure, service capabilities, and ability to withstand disruptions. Therefore, periodically reviewing and optimizing the network design using sophisticated modeling and analytical tools is not merely an operational exercise, but a fundamental strategic imperative for maintaining competitiveness and resilience in today's dynamic global environment. G. Lean versus Agile supply chains. Lean and Agile represent two distinct strategic approaches to designing and managing supply chains, each prioritizing different performance characteristics based on the market environment and product nature. Lean supply chain management. Originating from the Toyota production system, the Lean approach focuses relentlessly on efficiency, cost reduction, and the elimination of waste, muda, in all its forms, e.g., excess inventory, waiting time, unnecessary transport, defects. Key principles include standardization of processes, just-in-time, JIT, inventory management, producing or receiving goods only when needed, level production schedules, and a culture of continuous improvement, Kaizen. Lean supply chains excel in environments with stable, predictable demand and are typically suited for high volume, standardized, functional products with long life cycles. Advantages: significant cost savings through waste reduction and minimal inventory holding costs, high operational efficiency. Disadvantages: lack of flexibility to respond to sudden demand changes or supply disruptions, vulnerability due to minimal inventory buffers. Agile supply chain management. The Agile approach prioritizes flexibility, responsiveness, and adaptability to thrive in volatile and unpredictable market conditions. It emphasizes speed, information sharing and visibility across the chain, collaborative relationships with suppliers, and the ability to quickly reconfigure operations or ramp up/down production in response to demand shifts. Agile chains often utilize strategic inventory buffers, safety stock, at key points and may employ postponement strategies, delaying final product configuration until actual demand is known. This approach is best suited for markets with volatile, unpredictable demand, innovative or customizable products, and short product life cycles, e.g., fast fashion, high-tech electronics. Advantages: ability to react quickly to market changes and disruptions, better handling of demand uncertainty, potentially higher customer satisfaction through customization and availability. Disadvantages: potentially higher operating costs due to the need for flexibility, e.g., expedited transport, buffer inventory, less focus on cost minimization, more complex coordination required. The fundamental difference lies in their primary objective. Lean seeks efficiency in predictable environments, while Agile seeks responsiveness in unpredictable ones. This difference manifests in various operational choices, particularly regarding inventory strategy, minimal versus strategic buffering, and production approach, standardization versus flexibility/postponement. Recognizing that few supply chains face purely stable or purely volatile conditions, many organizations adopt a hybrid or legal approach. This strategy seeks to combine the strengths of both models, often by implementing lean principles in the upstream, more predictable parts of the supply chain, e.g., component manufacturing, and Agile principles in the downstream parts closer to the customer where demand is more uncertain, e.g., final assembly, distribution. Zara's supply chain is often cited as an example of effectively combining lean manufacturing for basic items with Agile responsiveness for fashion items. The choice between lean, Agile, or a hybrid strategy depends on a careful analysis of factors like product characteristics, demand patterns, volume and variability, product life cycle length, customer expectations, market competitiveness, and supply chain complexity. Table 4. Lean versus Agile supply chains comparison. Feature: Lean SCM, Agile SCM. Primary goal: efficiency, cost reduction, waste elimination. Responsiveness, flexibility, adaptability. Focus: eliminate non-value-added activities. Respond quickly to changing demand/markets. Inventory strategy: minimize inventory JIT. Strategic buffers, postponement. Production approach: standardized, level-loaded. Flexible, customizable, rapid changeovers. Demand type: stable, predictable, high volume. Volatile, unpredictable, variable volume. Lead time: focus on efficiency, can be longer. Focus on speed, shorter lead times prioritized. Key enabler: process optimization, standardization. Information visibility, collaboration, flexibility. Ideal product type: functional, standard, long life cycle. Innovative, customizable, short life cycle. Main advantage: lowest cost, high efficiency. High responsiveness, handles uncertainty well. Main disadvantage: vulnerable to disruption, inflexible. Higher operating costs, potentially less efficient. V. Integration, risk, and sustainability. Modern PNSCM operates within a complex ecosystem requiring careful management of interdependencies, potential disruptions, and growing ethical and environmental expectations. This section examines the critical roles of integration, risk management, and sustainability. A. Integration in PNSCM. Supply chain integration refers to the strategic coordination and linkage of business processes, information systems, resource flows, materials, finances, knowledge, organizational structures, and planning activities, both internally across different functional departments and externally with key supply chain partners like suppliers, customers, and third-party logistics providers, 3PLs. Integration is paramount because it breaks down functional silos that often hinder optimal performance. By fostering better communication, collaboration, and data sharing, integration enhances end-to-end visibility, improves operational efficiency, reduces costs, e.g., by eliminating redundant activities or optimizing inventory, increases responsiveness to market changes, enables better strategic alignment across the chain, and ultimately drives superior overall performance. Achieving the core objectives of SCM is heavily dependent on successful integration. Key dimensions of integration include aligning strategies, managing resource flows, coordinating processes and organizational structures, and synchronizing planning and control activities. Specific areas where integration is crucial include integration with finance. This linkage is vital for effective working capital management, aligning procurement payment terms, DPO, with sales collection terms, DSO, accurate cost analysis, including TCO, budgeting, and financial performance tracking. Furthermore, integration enables the implementation of supply chain finance, SCF, solutions. SCF utilizes technology and financial intermediaries to bridge the gap between a buyer's desire to extend payment terms, improving their working capital, and a supplier's need for faster payment, improving their cash flow. The financier pays the supplier early, often based on the buyer's stronger credit rating, and collects from the buyer later, creating a win-win-win scenario. Successful SCF requires close collaboration between procurement, finance, treasury, and accounts payable departments, often facilitated by integrated P2P and finance platforms. Integration with R&D/new product introduction, NPI involving procurement and supply chain teams early in the NPI process is critical for success. This collaboration ensures designs are manufacturable. Design for manufacturing, components are sourceable at target costs. Design to cost. Reliable suppliers are identified and engaged early. Material availability is secured. And the supply chain is prepared for launch, ultimately reducing development costs and accelerating time to market. NPI itself is a cross-functional process spanning idea generation, feasibility analysis, design, prototyping, testing, launch planning, and commercialization. Integration with operations/manufacturing, tight synchronization between supply chain planning, demand forecasts, inventory levels, and manufacturing operations is essential. This involves coordinating production schedules, MPS, ensuring timely material availability through MRP, managing shop floor execution, controlling quality, and aligning manufacturing capacity with planned supply chain flows. The ability to integrate seamlessly across internal functions and with external partners is a hallmark of mature and high-performing supply chains. This integration, often powered by shared data platforms and collaborative technologies, creates the necessary visibility, coordination, and shared understanding required to navigate complexity, respond rapidly to changes, agility, and withstand disruptions, resilience. Without effective integration, supply chains remain fragmented, inefficient, and vulnerable. B. Supply Chain Risk Management, SCRM. Supply Chain Risk Management, SCRM, is the systematic and proactive process of identifying potential threats, vulnerabilities, and disruptions across the end-to-end supply chain, assessing their potential impact, and implementing strategies to mitigate, monitor, and control these risks. The goal is to ensure the security, integrity, and uninterrupted flow of goods, services, and information, thereby protecting operational continuity, financial performance, and brand reputation. This includes managing risks associated with cybersecurity within the supply chain, cyber SCRM. SCRM has become increasingly critical due to the heightened complexity and interconnectedness of global supply chains, which exposes organizations to a wider range of potential disruptions. Events like the COVID-19 pandemic starkly illustrated these vulnerabilities. Common sources of risk include geopolitical instability, wars, trade disputes, sanctions, tariffs, economic volatility, inflation, currency fluctuations, natural disasters and extreme weather events, public health crises, supplier failures, financial instability, capacity constraints, quality issues, logistics and transportation disruptions, demand fluctuations, labor shortages, ethical breaches, e.g., forced labor, regulatory changes, and cybersecurity threats. Proactively managing these risks is often more cost-effective than reacting to disruptions after they occur and is fundamental to building supply chain resilience. SCRM is now considered a top priority for business leaders. Frameworks for SCRM often involve a cyclical process. Risk identification, systematically identifying potential threats and vulnerabilities across the entire supply chain, often involving mapping the value chain, suppliers, plants, warehouses, transport routes, and assessing each node. This includes identifying areas with data gaps. Risk assessment, analyzing identified risks based on their potential impact, financial, operational, reputational, and likelihood of occurrence. Some frameworks also assess the organization's preparedness level for each risk. Consistent scoring methodologies are crucial for prioritization. Risk mitigation, developing and implementing strategies to avoid, reduce, transfer, or accept identified risks. This is the core of proactive risk management. Risk monitoring, continuously tracking risk indicators and the effectiveness of mitigation strategies, often using digital tools and early warning systems. Risk control/governance, establishing clear responsibilities, often via cross-functional risk boards, policies, and communication channels for managing risks. Common risk mitigation strategies include supplier diversification, reducing reliance on single sources or single geographic regions by developing relationships with multiple suppliers, multi-sourcing. This includes strategies like nearshoring, onshoring, or regional sourcing hubs. Building strong supplier relationships, collaborative partnerships based on trust and transparency can improve communication about potential issues and facilitate joint problem solving. Enhanced visibility and transparency, using technology, e.g., tracking systems, blockchain, digital twins, to gain real-time insight into supply chain operations, inventory levels, and potential bottlenecks or disruptions. Holding safety stock/buffer inventory, maintaining strategic levels of inventory to cushion against unexpected supply shortages or demand spikes. Developing contingency plans, creating predefined action plans for specific disruption scenarios, e.g., alternative transport routes, backup facilities. Improving forecast accuracy, reducing demand uncertainty through better forecasting techniques. Contractual protections, including clauses in supplier contracts that address risk allocation, performance standards, and remedies for noncompliance. Cybersecurity measures, implementing robust security protocols to protect digital systems and data. Due diligence, thoroughly vetting suppliers for financial stability, operational capability, compliance, and ethical practices before engagement. While SCRM focuses on identifying and mitigating potential negative events, the concept of supply chain resilience encompasses the ability to not only withstand disruptions, but also to recover quickly and potentially adapt to emerge stronger. SCRM is a critical enabler of resilience. Effectively managing supply chain risk requires a strategic, cross-functional approach, supported by robust processes, data analytics, technology, and a culture that encourages transparency and rapid response. It is no longer an optional activity, but a core requirement for navigating the complexities and uncertainties of modern global supply chains. C. Sustainability and ethical sourcing. Sustainability and ethical considerations have become integral components of modern procurement and supply chain management, driven by regulatory pressure, investor expectations, consumer demand, and corporate values. These concepts involve integrating environmental, social, and governance (ESG) factors into sourcing and operational decisions. Ethical sourcing. This practice focuses on ensuring that products and services are procured in a manner that is responsible and sustainable, with a particular emphasis on social aspects like fair labor practices, fair wages, safe working conditions, no child/forced labor, human rights protection, and positive community impact. It involves evaluating supplier practices and ensuring they align with the organization's ethical standards and code of conduct. Specific concerns include avoiding conflict minerals, minerals sourced from conflict zones, financing violence, and ensuring the well-being of workers throughout the supply chain, including vulnerable groups like migrant workers or those in high-risk industries/regions. Sustainable sourcing/procurement. While overlapping significantly with ethical sourcing, sustainable sourcing often places a stronger emphasis on environmental impact. It involves selecting goods and services produced and delivered in ways that minimize harm to the environment, such as reducing greenhouse gas (GHG) emissions, conserving water and energy, minimizing waste, protecting biodiversity. Promoting sustainable land use, e.g., preventing deforestation in timber sourcing, and using recycled or renewable materials. Sustainable procurement integrates these environmental considerations alongside social and economic factors, the triple bottom line, planet, people, profit, into the entire procurement lifecycle. Key frameworks and concepts. ESG, environmental, social, governance, a broad framework used by investors and organizations to evaluate performance on sustainability and ethical issues. Procurement plays a key role in achieving ESG goals. Scope 3 emissions. These are indirect GHG emissions occurring in a company's value chain, both upstream from suppliers and downstream from customers, distinct from direct emissions, Scope 1, and emissions from purchased energy, Scope 2. Scope 3 emissions often constitute the vast majority, over 70 to 90%, of a company's total carbon footprint, making supplier engagement and sustainable procurement critical for decarbonization efforts. Strategies include prioritizing suppliers based on climate performance, mandating net zero commitments, collaborating on reduction initiatives, and promoting circular economy principles. Circular economy, an economic model aimed at eliminating waste and pollution, circulating products and materials at their highest value, and regenerating nature. In procurement and SCM, this involves designing products for durability, repairability, and recyclability, using recycled/renewable materials, implementing take-back programs, promoting reuse and remanufacturing, and minimizing waste throughout the life cycle. Sustainability certifications and standards. Various certifications, e.g., Fair Trade, FSC for forestry, B Corporation, Energy Star, Green Seal, ISO 14001 for environmental management, ISO 26000 guidance for social responsibility, help verify that products or suppliers meet specific environmental or social criteria, aiding responsible sourcing decisions. Implementing sustainable and ethical practices. This requires a strategic approach. Define standards and policies. Establish clear organizational standards and a code of conduct for suppliers regarding ethical labor, human rights, environmental protection, etc. Supplier screening and due diligence. Integrate ESG criteria into supplier evaluation and selection processes. Conduct due diligence to assess supplier compliance and risks. Transparency and traceability. Increase visibility into the supply chain, often beyond Tier 1 suppliers, to understand origins and practices, using tools like supplier mapping, audits, and potentially blockchain. Supplier engagement and collaboration. Work collaboratively with suppliers to communicate expectations, provide training or capacity building, share best practices, and jointly develop solutions for improvement. Monitoring and auditing. Regularly assess supplier performance against ESG standards through audits, assessments, and data tracking. Reporting. Transparently report on ESG performance and progress, driven by regulatory requirements, e.g., CSDDD, UFLPA, and stakeholder demands. Integrating sustainability and ethical considerations is no longer optional, but a strategic necessity. It helps mitigate reputational and regulatory risks, enhances brand value. Consumers increasingly prefer sustainable products, attracts investment, fosters innovation, improves resource efficiency, leading to potential cost savings, and contributes to a more resilient and responsible global supply chain. Procurement professionals are central to driving this transformation. 6. Technology in procurement and supply chain management. Technology is a critical enabler of modern PNSCM, providing tools for automation, visibility, analysis, optimization, and collaboration. This section explores key technologies transforming the field. A. AI, blockchain, and IoT. These three technologies are often discussed together due to their synergistic potential in revolutionizing supply chains. Internet of Things, IT, refers to the network of physical devices embedded with sensors, software, and connectivity, allowing them to collect and exchange data in real time. In PNSCM, IT enables real-time tracking and monitoring, tracking the location and condition, e.g., temperature, humidity, of goods in transit or storage. Technology is a critical enabler of modern PNSCM, providing tools for automation, visibility, analysis, optimization, and enhanced inventory management, providing accurate, real-time data on stock levels in warehouses or retail locations. Predictive maintenance, monitoring equipment health to predict failures and schedule maintenance proactively. Improved visibility, generating vast amounts of data that feed into other analytical systems. Artificial intelligence, AI, and machine learning. ML/AI involves creating systems that can perform tasks typically requiring human intelligence, while ML is a subset of AI where systems learn from data without explicit programming. In PNSCM, AI or ML applications include advanced analytics and forecasting, analyzing large datasets from IT, ERP, market data, etc., to identify patterns, predict future demand with higher accuracy, anticipate